Hello my dear children, welcome to my channel. So these are chemistry classes. But here you can see now same our CBSE board hydrocarbon chemistry, that is sample question paper. And now this is another question from the hydrocarbon that give mechanism of addition of HBr to propene. But these question they will ask in the exam for 5 marks. But this is a 5 marks question will be there. And obviously, but if it is a 5 marks, definitely we have to write in complete detail form of it. So addition of HBr to propene, here I should say propene means this is a propene, CH3, then CH, double bond CH2. This is called as a propene. This is a propene. And when we are going to add the HBr on it, to see beta addition of hydrogen halide. Actually HBr is called as a hydrogen bromide. So addition of hydrogen bromide to propene, and you know propene is a what? This is a unsymmetrical alkene. But this is a unsymmetrical alkene. So addition of hydrogen halide to the unsymmetrical alkene will follow the rule called as a Markownikoffs rule. And based on that, beta here I am going to get CH3CH, Br will attack here and H will attack here, where which will call it as a 2-bromopropane. This is called as a 2-bromopropane. And what is the rule it follows? The rule followed by it called as a Markownikoffs rule. But a Markownikoffs rule. So now we will see what is the Markownikoffs rule, and based on that how we are getting the 2-bromopropane. But according to Markownikoffs rule, instead of writing Markownikoffs rule, just I will write here M rule. But according to Markownikoffs rule, see H plus is a positive part and Br is a negative part. So negative part of attacking reagent, but a negative part of attacking reagent, negative part means Br minus, positive part means H plus. But two possibilities are there. We can say positive part of the attacking reagent attaches itself to that double bonded carbon which has more number of hydrogen. And one more possibility we can say negative part of the attacking reagent attaches itself to that double bonded carbon which has less number of hydrogen atom. So according to Markownikoffs rule, negative part of attacking reagent. But what is the negative part of attacking reagent? Br minus. Negative part of attacking reagent attaches itself to that double bonded carbon which has less number of hydrogen atoms. See beta, if it is a negative part, then it will attack on the double bonded carbon which has less number of hydrogen. But if it is a positive part like a H plus, it will attaches to that double bonded carbon which has more number of hydrogen. So anything we can write, right? So as our NCERT is using beta statement, what the NCERT statement is using, negative part of the attacking reagent attaches itself to that double bonded carbon which has less number of hydrogen. See beta, this carbon is having only one hydrogen and this carbon is having how many? 2 hydrogen, which has less number of hydrogen. Now based on that, this Br minus will attack on this carbon, so H plus will attack on here, and we got a 2-bromopropane, right? So mechanism, first you write down this one. What is the Markownikoffs rule that we wrote? Now we'll see the beta mechanism behind it. What is the mechanism, how it formed this 2-bromopropane? See beta, in the mechanism, HBr, it produces electrophile. What is that? H plus. This H plus is called as a electrophile in mechanism. But these electrophile will attack over the unsymmetrical alkene. What is unsymmetrical alkene? CH3, then CH, double bond CH2. And this H plus is called as a electrophile. But when it will attack on this unsymmetrical alkene, it form carbocation. See beta, your H may attack on here, it form carbocation, or your H may attack on here and it form carbocation. See beta, CH2 becomes CH3, so positive charge will form here. CH becomes CH2, so positive charge will form here. This is called as a secondary carbocation. This is called as a primary carbocation. As we know, primary carbocation is less stable and secondary carbocation is more stable. Right beta? So in mechanism में HBr form, it produces electrophile. Electrophile attack on unsymmetrical alkene and it form more stable carbocation and again less stable carbocation. But in this more stable, less stable में, this more stable carbocation which is formed here, see here, this is a more stable carbocation which is formed here. It is now attacked by the halide ion, that is Br minus, and we got here as a, see beta, Br minus will attack on the middle carbon and I will get CH3, CH, Br and CH3. This is called as a 2-bromopropane. This is called as a beta 2-bromopropane. Is it clear? Now we are going to discuss about here in this first part beta HBr attack over the propane, it follows the Markownikoff rule. Second part of it, what is that? If addition of this HBr over the unsymmetrical alkene take place in presence of light or in presence of peroxide, then it follow Antimarkrule rule. So please note down up to here. What you have to write beta in mechanism? Propene with HBr, Markownikoff rule form 2-bromopropane. According to Markownikoff rule, negative part of the attacking reagent attaches itself to that double bonded carbon which has less number of hydrogen. Means negative will attack here, so beta positive will attack here, and we got this 2-bromopropane. Mechanism means HBr produces electrophile. Unsymmetrical alkene, H plus will attack on unsymmetrical alkene to form secondary carbocation and primary carbocation. Among the secondary and primary, secondary is more stable, so it is obtained very fast. Means it is the formation of secondary carbocation will take place easily compared to the primary. This secondary carbocation now attacked by the negative part of it, that is Br minus, and it form 2-bromopropane. Okay, note down up to here beta. The second part of this I will continue. Now beta, second part of this one's here. This is an unsymmetrical alkene called as a propene and addition of HBr over it. But if this addition of HBr over the unsymmetrical alkene will take place in presence of light or when it take place in presence of peroxide, then beta, we are not getting as a 2-bromopropane. In that case, H will attack here and Br will attack here. It will be called as a 1-bromopropane. This rule is called as a beta Antimarkrule rule. This rule is called as a Antimarkrule rule, which is also be called as a Kharasch effect. It is also be called as an peroxide effect. So what is a Antimarkrule rule and what is a Kharasch effect and what is a peroxide effect? But according to Antimarkrule rule, see here, according to Antimarkrule rule, negative part of attacking reagent, but what is the negative part here? That is a Br minus. A negative part of the attacking reagent, negative part of attacking reagent attaches itself, see beta, attaches itself to that double bonded carbon, which has more number of hydrogen. See beta, Br minus will attack on that double bonded carbon which has more number of hydrogen. So Br will attack here, H will attack here, more number of hydrogen. And we got here product called as a 1-bromo-propane. But what is the mechanism behind it? See here, the mechanism behind it. But it will take place in presence of peroxide, and we are using here as a benzoyl peroxide. Now here mechanism will see it will take place in presence of peroxide, and here we are taking the peroxide as a benzoyl chloride. See what is a benzoyl chloride? C6H5 C double bond O, and this is a peroxy bond. O link with O called as a peroxy bond. C double bond O C6H5. But when this reaction take place in presence of sunlight, H nu means it will undergo homolysis. That is a equal distribution of electron. So it will break the bond here. This oxygen will get radical, this will get radical. It is something like that. C6H5 C double bond O. But O is having radical. Same way this part also O is having radical. So I will make it as a 2 moles. Now this part which one we got here, 2 moles of C6H5 C double bond O radical beta. It also undergoes homolytic cleavage and it forms 2 moles of C6H5. Carbon is having free radical. But these radical over the carbon and radical over the oxygen will make the double bond, and it is something like that. C double bond O called as a CO2. Instead of that we can directly write beta here CO2. How many? 2 moles of CO2 came out. Now these radical which one we got beta here, C6H5 radical will attack over the HBr. See beta HBr also I will write in the form of H bonded with Br. And now homolytic cleavage, this H radical will attack on the C6H5 radical, and now it forms C6H6. Now Br radical came off. Now this Br radical which one we got beta, this Br radical which one we got, it will attack over the unsymmetrical alkene. Now place is not there beta, I will take out this one and I will show you this part here. Please up to your note down. Now beta this Br radical which form here, this Br radical, beta it will attack over the unsymmetrical alkene. What is that? CH3 CH double bond CH2. But it formed 2 radicals here. One is a radical obtained on this part and this Br will attack on here. And second possibility beta, CH3 your CH Br and radical will form on this carbon. See beta carbon atom having radical, this radical carbon will attack with 2 or attach with 2 carbon. This is a secondary carbon free radical and this is a primary carbon free radical. Secondary carbon free radical is more stable and primary carbon free radical it become less stable. But which is become more stable? Now in that one the remaining part of it, what is that beta? H plus will attack over it, right? Please up to your note down, I will take out this part also. Now beta here more stable carbon free radical is here. This one you have to take CH3, then CH radical, then CH2 Br attacked by HBr. But here also homolytic cleavage will take place. H radical attack on this one and it will form CH3. CH becomes CH2 and we are having CH2 Br. See this H radical attack on the CH radical and CH radical become CH2. Remaining CH2 Br as it is and we got here as a Br radical. This is a beta major product obtained by the Antimarkrule rule. Name of the compound is 1-bromo-propane. Called as what beta? 1-bromo-propane. So to write this answer for 5 marks, first we have to mention or we have to give the explanation for addition of HBr to the unsymmetrical alkene that is propane followed by Markownikoffs rule. That complete explanation we have to give, and afterward beta addition of these HBr over the unsymmetrical alkene like a propene in take place in presence of sunlight or in presence of peroxide. But in presence of sunlight and peroxide, it will favor anti-Markownikoff rule, and this anti-Markownikoff rule is applicable only with a peroxide and HBr, but not with the peroxide and HCl, not with the peroxide and HI. It is only applicable, anti-Markownikoff rule only applicable with a peroxide and HBr or light HBr, and that to be over the unsymmetrical alkene. So this complete explanation for this question for 5 marks will get it, right? Thank you beta, thank you very much. Just you can see here, and if you like these videos and all, please like it, share it and subscribe it. Thank you very much.